Ja, ich sag nur, put your hands together für Pau.
Well, thanks everyone for coming. And after talking about shit in different forms, let's talk about trash. It's one of the hallmarks of human civilization, so to say. Wherever humans go, trash follows. Doesn't matter if it's the ocean, a city, and surprisingly, this also extends to space. This is a picture from NASA. Every white dot is a dead satellite that they keep an eye on, just to see where it goes and basically to keep track of them. Now, you may wonder why care. I mean, it's just floating around in space. It's not going to poison your food or your water. It's not going to make any cute animal choke. But it does pose a problem. If you've seen the movie Gravity, you may have remarked that the plot moves around space debris colliding with International Space Station, and just creating the whole movie. And that's actually the problem, that basically all of those pieces of metal are just floating around. They may actually collide with each other or with alive satellites. This is obviously a problem. So, getting rid of them, it's easy because you just have to throw them back to Earth. They will disintegrate in the atmosphere. The problem is to catch them. How do you catch things that are floating around? Well, you fish them. And basically, you throw a big net, it entangles on the satellite, and then you throw the whole thing down. Obviously, it looks a bit more like that, but the idea is exactly the same. Now, there's a couple of problems with the approach. The main one is that if the net gets entangled with the satellite, you have to throw down both. Therefore, if you want to throw down 10 satellites, you need 10 nets. That's not very efficient, so we would likely try something more like this. It's basically a robot that has a robotic arm, grabs a satellite, throws it back to Earth. It's yeah. Now, until now I've just been talking about what's going on. Now, this is when I joined that project. Basically, I was working on this satellite that, again, it's a robot that takes trash and that goes to space. Does it ring any bell to anyone? No? Yeah. So, it gets even cooler because I was actually working on the intelligence of that robot. That is, how does it know where to look for? How does it find the dead satellites? In which positions are they? All that stuff. And I just came out, when I was joining that, I just came out of university. So I'm going to try all those cool algorithms that I just learned in college about neural networks, about artificial intelligence, and I'm going to plug them in and they're going to work in space. Well, not really. Basically, the space industry, for all its high tech, it's extremely conservative. Whenever you launch something in space, it has to be something that has been tried on Earth, tested, and retried for 1,000 times. Whenever you work with a satellite engineer or anyone in space, they want to know exactly what could happen. So anything that learns by itself, anything that's, let's say, intelligent on its own, doesn't work for them. Another problem is that any of your smartphones or laptops out of the atmosphere would not work. High levels of radiation creates small currents in your computers, and that pretty much fries every circuit. To work, you have to use computers from the 80s, which, well, it's a bit restrictive if you are a computer scientist. So, I'm an engineer, and when you cannot solve a general problem, you solve a specific one. Now, this is the main target that we would really like to get down. It's the MVSAT, a satellite that was launched in 2010. It has the size of a small bus. And in 2011, we just lost contact with it. Nobody knows why. It just stopped working. And it's floating around. Yeah. And one thing that you'll notice is that actually with the MVSAT and with most satellites, they're made of relatively flat and regular surfaces. There's the squares, there's rectangles, all that stuff. And that's really good, because recognizing a potato may be difficult. Recognizing a triangle, a square, even a child can do it. And even a robot, actually. So that's exactly what I did. I took a miniature model of the MVSAT, found out the main flat surfaces that I could identify, and then just said, to the camera, just look for those surfaces, and once you find a few of them, you would know where the satellite is. Easy enough, you take a picture of the satellite in 3D, and you decompose flight surfaces, you find them, and you find the position of the whole satellite. And that's pretty much where I left. I mean, I left that basically in 2014. The project is still going on with people hopefully smarter than me. But what I want you to remember from this talk, it's a pretty simple idea. Don't throw trash. I mean, when somebody comes and tells you, yeah, we have a small flotilla of satellites that move around the Earth and that's going to give you 4G in the middle of the Sahara, just think for a second that you may not need 4G on the Sahara and that this may come at a price, the price being the future of space exploration. You may say, well, you know, we have stuff that cleans the space. I mean, that's what I was doing, and that's what, say, many people are working on. And that's true, but those things have a limit. Like my approach only works if you know what you're looking for. If you have scraps of metal in general, that's much more complicated. And to solve that, we'll have to make a lot of very smart robots, which, if Hollywood says anything, is not really a good idea. So that's everything, and thank you very much for your attention.